Hello Internet. Today we have this fancy laptop from Lenovo called Legion 5 for a good reason. Thanks to the owner's greasy fingers, it now has a legion of problems that we're going to fix. We start by wiping away the owner's grease and herpes, and verify that the laptop is indeed dead. Possibly because the battery is disconnected. I don't know. All I know is that the owner was poking around and something shorted. Battery is not short. Other nearby coils don't read short, but this one here does. Not sure where that goes, so we're gonna have to take this thing apart and see where it leads. There. A blown MOSFET and a chip. At this point, I don't know what this chip is, and I don't care. We'll figure it out later. In any case, the beauty of electronics is that they like to break the moment you touch the guts. So please, continue touching your electronics guts so I can have a steady supply of work. Thank you for your support. Either way, with some heat shields in place, let's try to remove these chips without damaging the board. Parts are removed, the affected area is prepared for the part swap, so let's check the reading, and the short is gone.
Perfect.
All other readings seem to be okay, so next we need to either use the board view or schematics to identify faulty components. The memory seems to be powered by the RT8231, and this one is a common N-channel MOSFET. I don't have this exact one in stock, but I have one rated for higher amps. That will ensure a good size hole in the event of a similar failure. So let's solder what I have on the board, and then a week later, solder the memory voltage regulator and see if that helps. Flipping the power switch and expecting it to blow up, I see nothing. Nothing blew up, and there's no standby voltages either. I don't know if 3.3 or 5 volt comes first, so all I can do is to look around and see if either one of them have a problem. So I'll start by looking at the 5 volt first and see if there's any kind of voltages near the 5 volt regulator. And there's 0 volt everywhere I test. It doesn't even have the main 20 volts input anywhere. Not even at this shunt resistor, which actually reads dead short.
Oh my God!
So let's inject voltage into this shunt resistor and see what lights up. I am injecting voltage somewhere else, but it's all connected, so don't get confused. It seems like the only thing that warms up is the GPU core. But looking up close, we have a shorted driver MOSFET. So let's replace that and see if that helps. Okay. Driver MOSFET replaced. The short is gone, so let's power it on and see what happens. There. It powered on by itself.
Perfect.
Now let's put this thing together and see if it posts. But before I do that, I'd like to point out that someone has ripped the locking mechanism from this port, so I cannot reconnect the ribbon cable. I don't know what this ribbon cable does. Maybe LED, not sure. I don't have these sockets anyway, so I can't do anything about it even if I wanted to. With mostly everything connected and the battery plugged in, nothing seems to be turning on by itself, and the power button stays lit, but nothing seems to happen. Until I flip the laptop and look at this. One of the memory modules and the NVMe drive are both glowing like mad. I don't know if the NVMe is supposed to do that, but the memory surely does not, and no wonder. We have a short on memory. Removing shorted memory module makes short go away, but the laptop still refuses to boot.
I hate you!
So I said to myself, screw this, I'm gonna try my own memory I have laying around. And we have a picture. It doesn't seem to recognize the NVMe drive, so I assumed it was also dead. So I used my own to test and see if it will boot. And since I like to keep myself occupied, while the laptop was booting, I measured my nose. And I'm reading about an inch, if anybody cares. So basically, what we have is 2 dead memory modules and a potentially dead NVMe drive, which I later discovered that the drive was simply corrupted and actually worked. It just needed to reinstall the operating system, and by that time I applied fresh thermal interface, and I found that the CMOS battery was also reading less than half of its capacity, so that needed to be replaced. And in case you were wondering how to identify the battery that you need, simply remove the plastic film and read the battery model. This one is CR 2016. Now you know. Later next week, a second NVMe drive and the 2 replacement memory modules arrived, so let's pop them in and see if it still works. Okay, now let's install Windows and run some tests. That's it for this repair. Hopefully I earned your like and subscription. Goodbye.